So let's continue our lesson on the sample variance and the standard deviation. This is the last example that we did together, example 8, and we had to calculate the sample variance and the sample standard deviation of the speeds of these 5 new automobile brands. We entered the list into the calculator, we calculated the sample standard deviation, and then we squared that to get the sample variance. We're going to do another example, but before we do that, I kind of want to just summarize what we discussed in the last lecture. So let's first talk about the relationship between the variance and the standard deviation. So the variance is equal to the standard deviation squared. So if I know the standard deviation and I square it, I get the variance. But I could also go the other way around. I can calculate the standard deviation if I know the variance. I would take the square root of the variance. So if you have one, you could calculate the other. So for example, let's suppose the sample variance is 36. What is the sample standard deviation? And remember in the previous lecture, I said I'm going to use SD for short for standard deviation. So suppose the sample variance is 36. What is the sample standard deviation? So the sample variance is S squared. We know it's 36. Now I want the sample standard deviation, which is S. That's what we're trying to figure out. But remember the relationship between the two. The standard deviation is equal to the square root of the variance. So S is equal to the square root of S squared, which is going to be equal to the square root of 36, and that would be 6. Let's do another example. So let's suppose the sample standard deviation is 4. What is the sample variance? So the sample standard deviation, S, is 4. And I want the sample variance, which is S squared. So in order to get the variance from the standard deviation, we square the standard deviation. That's going to give us the variance. So S squared is equal to 4 squared, which is 16. So that's the relationship between the variance and the standard deviation. Now, before we do another example, I also want to talk about, let me just get to another page here. So I also want to talk about what it means to have a higher standard deviation versus a lower standard deviation. So remember, the standard deviation measures or tells us the average deviation from the mean. So the higher the standard deviation, that implies that there's more variability or more deviation from the mean in the set. The smaller the standard deviation, the less variability in the set. So let me write this down. So the larger the standard deviation, the more variability in the data set, which means less consistency, right? Because if there's more variability, there's less consistency. The set's not as consistent because there's more spread. The smaller the standard deviation, the less variability there is in the data set. And that means that there's more consistency if there's less variability. So that's how we interpret the standard deviation. That's another way to look at it. So let's do one more example. So let's look at example 3.19 here. So it says, two high school women basketball players are being considered for an award to be given to the most consistent player with the highest scoring average for the season. The number of points scored per game for all the games played during the season is given below. So calculate the population mean and the population standard deviation of the number of points scored per game for each player, and then use the results from part A to determine which player should receive the award. So the first thing we have to do is, because we'll use the calculator to get the population mean and the population standard deviation for each player. So the first thing we have to do is enter each player's points into a list in the calculator. So if you want, pause here and enter each player's points into two separate lists in your calculator. So for player A, you're gonna put the points into a list, and for player B, you're gonna put the points into a list. And for each one, we're going to do a one variable stat so we could get the mean and the population standard deviation. So I already have the two lists in my calculator. Player A, I put in list 3, and player B's points, I put in list 4. So we're going to do a one variable stat on each. So the first I'm going to do L3, I'll do player A first. So remember, we press stat, we go over to calc, we choose one var stats. I have to change the list to L3, leave frequency list empty, and then we're going to calculate. So the first thing that the calculator gives in the output is the mean. Remember what I told you when I first showed you how to use one variable stats to get this output? The calculator by default always writes it as X bar, but like in this case, we're assuming it's a population and I want the population mean. So the population mean is equal to 23, and I want the population standard deviation, which is sigma. So I'm going to look down here at sigma with the little X next to it. And that will go two places. So that's going to be 13.24. So this is for player A. So let's write this down. So for player A, the population mean is equal to 23 points. And the population standard deviation is equal to 13.24 points. And now we're going to do the same thing for player B. We're going to calculate the population mean and the population standard deviation for their amount of points. So back to my calculator, press stat, over to calc, one variable stats. And now I had that player's information in list 4. So I'm going to change this to L4 and then calculate. and we get a population mean equal to 23. So remember, it gives us the sample mean, but we're assuming this is the population. And now we need the population standard deviation, which is sigma. And the calculator uses sigma with a little x next to it. So that's 5.48 if we go two places. And we'll write that down. So player B had a mean of 23 points and a standard deviation of 5.48 points. So now we want to compare our results. So part B says, using the results of part A, determine which player should receive the award. And I put a little reminder here, and I also had it on the whiteboard earlier. Remember, more consistency means a smaller standard deviation, right? Because that means less variability. More variation means a larger standard deviation. Dispersion is another word for spread. So the greatest dispersion means that there's a larger standard deviation. So the higher the standard deviation, the more spread, the more variability, the less consistency. The smaller the standard deviation, that means the smaller the spread and the more consistent the data values are. So now this award is going to be given to the most consistent player. So with the highest scoring average for the season. So now notice both of these players had the same average. They score about 23 points on average. They both had the same average. However, which player is more consistent? So in other words, which player has the smaller standard deviation? And that's going to be player B. So player B is more consistent. So player B should receive the award because she was more consistent, meaning she had a lower standard deviation than player A. So I think after we did, this example, and then the example that I gave you on the whiteboard and the previous example that we did in the last lecture, it should be, you should be a little bit more comfortable with how to interpret the standard deviation and what the relationship is between the variance and the standard deviation. So in the next lesson, we'll move on and we'll cover the empirical rule.